Production and factory settings bring their own set of hurdles for wireless connections. Harsh conditions, both indoors and out, create a daunting task for engineers to work through. Now let me tell you, those engineers ain't looking to back down from a challenge like this, no sir. This here's where we gather round to tackle them hurdles, swap thoughts, and lend a hand. Welcome to the Industrial Wi-Fi Shop with your hosts, Scott and Jeremy.
Hello, everybody, and welcome back to another episode of the Industrial Wi-Fi Shop. My name is Scott McNeil. Welcome to episode 19, CURWB Appeal. We got a good show ahead of us, and it's going to be a good time. As usual, though, I want to go over some housekeeping things right quick. Jeremy still has his 3D printer plans up for WiPry and Clarity Lucids. That is listed on Thingiverse, and I think he's going to be putting it somewhere else. Is that right, Jeremy?
Yeah, that's correct. I'm going to put it on Printables as well.
So that's free for downloads if you guys want a nice little hanger for those devices on your laptops. We got some upcoming WICO events in September. September 10th is UK South London. Then in October is, for all you crazy Canucks, the Montreal, Canada, and on October 1st. Back down in DC for Washington, DC for November 6th. And then out in the Netherlands, I'm not even sure how to pronounce that. November 19th, I'm going to totally botch this. Utrecht? I don't know. That's the American pronunciation of it. Maybe I'll drink a beer and throw some Southern accent behind it and turn it into something completely different. WLPC is right around the corner in Valencia, Spain, in September. So the 12th to the 14th is their boot camps, with the main conference on the 15th and 16th. And then Prague, probably the second biggest one as compared to WLPC Phoenix, in October, 11th to the 13th for boot camps, and then 14th through 16th for the main conference itself. So Prague is always a really big deal, just like Phoenix is. Hopefully, Spain's will get that big too. Meanwhile, Jeremy, you have another giveaway in store for us. Is that correct, sir?
That's correct. Keith Jones, the CEO of the company I work for, Prism Systems. We've developed a commissioning tool for the Cisco URWB product that basically enables the telemetry to be visualized and then post-processed. And he's provided 2 license codes for that. So probably how we'll do it is, if you actually have a need for it, apply for it, and then I'll get you a code for it. Then you can get it through the App Store on iOS. It does require an iPad or a MacBook to run. So I'm sorry for anybody that doesn't like Apple products currently.
After we get done recording, we'll put together a Google entry form for those who are interested to get one of those licenses. Also, don't forget, we have our new document library live and online for quick reference sheets and some best practice guides. It's free tools to help you do your job better. So check those out when you can. Guys, today we got a great show. We're going to be talking about what was once Fluidmesh and is now known as ultra reliable wireless backhaul. A lot easier to say after you've had a few drinks. And with us today, we have Matt Virus and Igor. I'm going to butcher your last name, so I'm going to let you go first and let you go ahead and say it.
Sure. My name is Igor Moiseev. So been at
Cisco. Yeah, I would have butchered that.
Oh, all good. Yeah, been at Cisco for about 5 years, pre-sales engineer. And then prior to that, came over as part of the Fluidmesh acquisition in 2020 and just been going at it ever since.
How about you, Matt?
Hey, Jeremy, just to make you and Scott feel better, my name is Matt Virus.
So, I was going to say Virus, but I didn't.
See, look at that.
I didn't want to correct.
So be it. Yeah. So thanks for the invite, guys. Yeah, I've been at Cisco for quite a while, and happy to be here and talk to y'all about CURWB and wireless and all the crazy stuff that I've done, along with a lot of support from Igor over the years.
Well, I appreciate you guys coming on. Before we dive into it, I just do want to talk just a quick second about the history of, well, everybody loosely calls it CURWB, but ultra reliable wireless backhaul. Back in the day, it was Fluidmesh. And Igor, correct me if I'm wrong, but around 2005 is when they came on the scene. Maybe was it earlier than that, or does that sound about right?
Nope, sounds about right. January 2005, so they just had their 20-year anniversary a few months ago.
I used to pal around with Don Lin a little bit, and learned quite a bit from him. And Fluid Mesh was heavy into ports and high speed rail, and so in the mobility game for a long, long time. And then Cisco decided to buy them up around 2020, and then changed the name to the ultra reliable wireless backhaul. Now, was that originally a Fluid Mesh thing, or was that a Cisco rebrand?
I would say it was a Cisco rebrand. I want to say they wanted to compete with UR LLC from the 5G side.
Okay. All right. Well, that makes sense. And then, from and it's just been blown up ever since. So, but one thing a lot of people need to understand is that CURWB is not 802.11. It's an MPLS overlay onto wireless technologies. And all MPLS is a faster, more efficient form of routing. So Matt actually has a great explanation of that. We can dive into that later as we get deeper into the technical stuff. I really appreciate you guys coming on the show. And you know what? Let's just start off with some basics. How does CURWB work, and what really is the kind of the on a broad level the secret sauce that makes it ultra reliable?
Yeah, so I think the main things about CURB are that you need to really think of it as wireless fiber. If you have Ethernet on one end, Ethernet on the other, and like you said, it's not Wi-Fi. So when we start talking about what makes it ultra reliable, there are a lot of things that we can do with a CURB deployment to increase the likelihood of packet delivery. So one thing, we have MPO, multipath optimization, where you can have a client radio that's out in the field, or a distant end radio that can send its telemetry stream, its data stream, to multiple trackside radios or multiple radios at the edge of the wired network. And then there's a gateway that can take those two streams of data and compare them and make sure that they're congruent. If one stream has a packet missing from the other, those two packet streams can be reassembled and put together such that the loss from that client at the far end, or the loss of that network at the far end, is completely wiped out and nullified by taking the multiple packet streams and putting them together. And there are a number of other things that we do to make it ultra reliable, whereby we can have a client radio that's in motion, and it is constantly examining all of its peer radios. So we talked a little bit about how there's a component of MPLS to the overlay that's built when these networks come online and when they discover peers. When a radio if it's deployed in fluidity mode or mobility mode, as it moves around, it's constantly looking for peer radios to build a neighborship with. And then depending on KPIs, RSSI, signal strength, signal throughput, that client radio is able to modify its data path. And we're able to do that by manipulating the MPLS label and manipulating the underlay. And we do that in software on the radio itself. And it's a constantly running process. So when we do that, we're able to flip from one trackside radio or one uplink radio to another uplink radio with 0 milliseconds of latency and 0 packet loss. So when we're doing all of this crazy, nerdy, in the weeds stuff, what it essentially means to users, to OT protocols, to IT protocols, whatever is running on the network, it means that the user has no idea when a roam or when a migration happens. Not only does the user not know, the application itself doesn't know. All of this happens so seamlessly and so quickly that the applications just function. We don't lose any traffic. We don't have to re-authenticate. We don't have to resume sessions. Everything just kind of continuously continues to work. The connections are migrated from trackside radio to trackside radio as we move, and everything and everyone on the network is happy, and people like you and me don't get calls about things being broken or slow, and those are good days.
But where that's
So
really
would it,
important is in machine to machine communication, right? Because it's a little bit different than an end user with cat videos. Because who cares if a cat video gets a little bit of lag, but if when you have a machine to machine communication scenario, if they lose communication, well, that can stop a process, that can create all kinds of problems. You can trip safety, so on and so forth.
Right, but we're absolutely not saying that cat videos don't matter. So please, no hateful comments about us and cat videos.
We'll add some cat videos to the show notes. So would you say would it be fair to maybe describe a client leaving one connection as sort of like an Irish goodbye?
Yeah, I would say that could work.
I think it sends the one packet to update
Gratuitous art.
the table. I think it's the MBR table.
Yep,
I
yep.
hope I don't.
Yeah, and then another packet to tell other people how to get to it, since you've now roamed to another AP.
Mhm.
So not quite an Irish goodbye. You'll know where to find them, but it'll kind of maintain that.
It's a little like chest bump and peace sign.
Yeah, right. And you'll say, "Hey, I'm going to the next bar down the street. Go find me there."
And then I think it might be worth mentioning, NPO is not necessarily like an always implemented feature, but it is when you want to add the additional redundancy in a lot of our deployments. That's where you'll get that. And then in the licensing, that's not necessarily readily available at the essentials, like the basic level. That's more the advantage in Premiere is where that comes in. Just for if you're out there listening and trying to figure that out.
Sure. Yeah, and also along with MPO, the notion of fluidity or mobility isn't in the essentials license. You have to bump up to higher level licenses to capture that feature and to capture different amount of throughput available in those features too. Yeah.
Yep. And then it also the throughput is also dependent on the radio model you use too, depending on the tier of licensing that you use.
Yeah, somewhat. Generally, across the line, there aren't, for point to point and point to multi-point, there aren't any throughput limitations for
those are
fixed configurations. But you do bring up a great point that the 9165 runs at 2x2 MIMO, but the 9167 can run at 4x4 MIMO. It requires a wider channel, 160 megahertz channel. But on 160 megahertz channel with the 9167 in 4x4 MIMO mode, you can push well over a gig at a fairly significant distance. I'm reluctant to throw out distances because then we get nailed to the wall with, you said it could do this. So I'll tell you that we've done a gig at a mile. We've done a gig at slightly over a mile in 4x4 MIMO in specific conditions with specific antennas. So if you try to do it, if you futz around a little bit and have the right stuff, it'll work at that distance with kind of, if you pay attention to your KPIs and deploy it like you're supposed to, you can easily get a gig at a mile at 4x4 MIMO, but it is kind of dependent on spectrum and all those things. So it can be done. I'm not saying that it's going to work every time just because we are in spectrum that doesn't require licenses. So sometimes you have to get creative and hunt around for open channels and things. But 4x4 versus 2x2 is a hardware separation from the 9167 to the 9165 radio. So that's
so you're saying that 60% of the time it works every time?
Yes, exactly.
The 9165s I was really impressed with. I did a deployment of these at a paper mill in the wood chip yard, and it was originally done in Fluidmesh, and we finally got to the point where we had to do a rip and replace because we couldn't get the old Fluidmesh models anymore, and they just wanted to have some spares. And when they found out they couldn't get spares, after 4 years of we did the installation, and then I didn't hear from them for 2.5 years. They just went completely off the radar because everything just worked. 2.5 years later, they gave me a call. Hey, can you help us? We had a really bad storm. One of our radios filled up with water, and we didn't even know it because it kept working for 3 months on the one base radio we had set up, so we didn't have high availability failover. That's a smooth system when you don't even know one of your redundant bases went down because everything just kept working. Anyway, so we ended up doing a whole hardware refresh, and we refreshed them with the 9165s. And what a boost in hardware capabilities compared to the FM 4500s. I mean, it was probably a solid 10 dB difference increase in signal strength across the board for everywhere these things connect, and it was impressive. And it was a stable deployment to begin with, but even more so now. So I was really impressed with that series of radios. Easier to install and handle too.
And no
Versus
more QMA adapters.
Yeah,
Nope.
and you're getting two radios in one package. So those FMs were single radios. So now you're kind of getting a BOGO with the
Yep.
9160 series.
No M12s to deal with. I was very happy about that.
Yeah, you
Well,
can add them on if you need them for your site requirements, but RJ45 all the way.
and Igor, this is a question I probably should ask you offline and not put you on the spot. But on the 9165Ds, is that internal antenna, that internal directional, is that like used on other radios in the Cisco family as well?
So that one was specifically designed for the IW product. So it's
Okay.
15 dBi panel, so about 30 by 25 for your beam width.
Okay.
And you can also buy it as an external antenna. So if you search PNL 5615,
Yeah, 5615.
yeah, so it's a 5 and 6 gigahertz rated panel antenna. So if you wanted to do, say, a point-to-point relay off of that 9165D, that would be kind of a suitable assembly there.
Okay, because that's not, I think some of the like planning software we have that we use, it's not, that antenna pattern is not in there. So I've been looking for something similar to kind of fake it.
Yeah, let me know what platform you're using. I can get with our engineering and see if we can fill in those antenna profiles with Hamina or Ekahau or whatever tool you're working with.
Okay, yeah, I'll do that. And then I guess since we're kind of talking about hardware, so there's the 9165D, which has the built-in, it's the 2x2 built-in directional that Igor just described. And then you've got the two in female antenna ports on the top for the second radio. And then there's the 9165E, which is basically it's the same chipset hardware, correct? Just in a hardened package.
Yeah, same chipset, smaller form factor, and that's more suitable for, say, like an AGV deployment. So small form factor, IP30 from a waterproofing perspective.
Yeah, and then they have is it GNSS, the GPS antenna capabilities on board the radio too.
That's right.
And then those are 5 gigahertz or 6 for the radio.
Yeah, the one
Right?
with the 65 series, slot 1, radio 1 is 5 gigahertz, slot 2 is 5 or 6. So we are missing 2.4 if you're going to run that AP in a Wi-Fi mode, for example.
But it is present on the 67s.
Yeah.
And then there's several flavors of that. I think there is an internal antenna version of that. And
Well,
then
the 67 that's internal is Wi-Fi only. That might change
okay.
going forward, but it's Wi-Fi only right now, and it's an Omni internal, so it's meant to be like ceiling mounted with the face of the AP facing down to the floor, and it doesn't have any external connectors or anything. It's meant to just be installed in that orientation, and it's 2.45 and 6, but it's Wi-Fi only right now. Then there's a 67 and then a 67 hazardous location SKU as well. So there's one that's just kind of ruggedized, and then one that's hazard location certified for chemical plants and specific vendors that have that requirement for
all the places you love to go to, and then just say, is today the day? I did a sugar plant a couple of years ago, and they were like, you got to be really careful, because if something bumps or whatever, that that powdered sugar could like create an arc flash. And they were like, the silo blew up 30 years ago. It's like, okay, this is fun.
So with all the flexibility and everything, and the all the different application types, a couple of questions I've got. One, how and I guess I don't know how to properly ask it. How well does it perform in leaky coax deployments? Radiant cable. Does it just standard normal operation, no differences? Any special things you have to do with the radio specifically, or is it just, like I said, normal day-to-day stuff? It just doesn't care.
Have either of you done any of those deployments?
I've done a few. I would say they're uncommon,
Okay.
but it does work well. I mean, the leaky coax to me is just a antenna in your coax with that slot. And as long as you're terminating it properly and making sure you're not stretching that cable too far, it should perform well.
Yeah,
Um,
I think the only thing you kind of get limited to on that is that for the ones that we've done, you're kind of limited to CISO only mode, so you only get the one stream. But we are looking at a company that has claims they have a way to do MIMO on our coax, so we're supposed to be getting some test hardware on that. So it'd be nice to at least get like a 2x2 in some of those deployments for a little bit higher throughput capability.
yeah,
And then
or
what?
ask them to
And
run
then
another coax cable and have more or less two leaky
yeah,
antennas with. Yeah, you
and
are.
then also we've done some things where like off of a single like a 9165 just running to either two frequency segments of coax or into one, just in feeding both ends of the coax, and then just doing like a big free, like a uni one and a uni three channel on them.
Yeah, I mean, we've seen a couple instances there, and also train the ground applications for those really tight tunnels. Sometimes you don't have the clearance to put a panel antenna and also have it off the wall. So yeah, definitely keep that in mind as kind of another antenna you can use in
So
addition to the.
do you lay up there with your data receiver on top of the train and ride through the tunnel, or
Not recently, it's been a couple years.
Are there, I was just looking through some of our notes, and are there plans to move current functionality into 6 GHz?
Yeah, I mean, that's what we've been told. So step one was the integration into the 9800 controller. So that controller acts as your AFC proxy, which will unlock those 6 GHz capabilities for URWB eventually.
So you guys are moving URWB configuration abilities into controllers too?
That's correct. So yeah,
Oh,
the software was just released last Friday, so 17.18.1, and one of the new features there is URWB configuration support with that 9800 controller.
so you log into your controller and you configure it there, and it just pushes everything out to your radio, so you're not having to go radio to radio and individually log in and configure them.
Yeah, that's right. Obviously, I'd recommend pre-staging them, maybe assigning a static IP. Yeah, it's definitely used as a mass configuration platform and also enabling Wi-Fi on that same AP. So instead of a two-box solution where you had backhaul and Wi-Fi access, you could do a one-box solution and just define different profiles to slot one and slot two.
Well, that's kind of a game changer, especially for all Cisco shops that are looking to incorporate mobility into other things, and then it consolidates control and configuration all into one box. That's a huge deal when you think about it.
It is, and it makes deployment on poles and a lot of things a lot easier. You only need one power injector or one 48-volt line. I don't have to have two or three radios, and it gets really interesting for mobility or fluidity applications too. There are had a lot of customers that have, let's say they have a forklift and they're in an inventory yard and they maybe have a Wi-Fi scanner that they use to scan different items as they pick it up and put it down. But the scanners don't like to roam, so they'll cover the forklift or cover the storage yard in fluidity, and then they'll have a fluidity client radio, maybe in a 9165E on the forklift. Well, previously they'd have to have that 9165E in Fluidity client mode and then have a second 9165E running in Wi-Fi mode. And the Wi-Fi mode radio would ride the curb connection back to the controller and everything would work. So they'd have this Wi-Fi bubble at the forklift that would allow that scanner or that device to never have to roam. It would just always be anchored to that SSID from the forklift. But now in a 17.18.1 world, we'll be able to have that 9165E or 9167 radio on the forklift. It can run in Fluidity client mode and attach to the curb network at large using Fluidity. And then the 5 gig radio or the 2.4 gig radio in that same 9167 or that 9165 would be able to broadcast a Wi-Fi network as well in one box. So you don't need a switch anymore. You don't need multiple Ethernet cables. You don't need multiple power. You can just take a 9165, throw it right onto vehicle power, forklift power, 24 volts, whatever you've got, and get that single radio up and have Wi-Fi and curb fluidity, everything from just one box. So it really
That's a pretty
simplifies
big,
things.
that's really kind of the one of the main scenarios I was thinking about as we were talking about this, is scenarios very similar to that, not only for like fork trucks and moving things around, but also open pit mining. I could see where that would be big for that, because conceivably then you can place wireless sensors throughout your vehicle, have them connected up to that device, and then reporting back via the backhaul. And it's a whole lot cheaper to mount wireless sensors on a vehicle than it is wired. So cost effectiveness makes it that's a huge deal right there. Yeah, that opens up a lot of different possibilities, especially if you can get smaller curb client radios versus the big boys that
Mhm.
most that I've dealt with are, and that they are capable of 24 volt power supply or to them. Is that correct?
Yeah, I have to check the data sheet, but I think the cutoff is right around 20 volts, like 24 to 48 volts is kind of our
Okay.
nominal range. So they'll almost run from 18. I've tried, but I think you got to get above 20 volts to have it power reliably. And so yeah, they can run off that.
So
I do a lot.
your standard DIN rail mount industrial power supply be able to power one of those without a problem.
Yeah, and the other things you can get really inexpensive voltage boost converters that'll take from 12 to 24 volts and kick it out to 48 volts. That's really common. We use them a lot for I do a lot of farm stuff and a lot of farm deployment, so I use those converters a lot for the vehicles that I put equipment on, so they're pretty easy to work with. And then there are switches like the IE3100 is a PoE switch that will take 12 volts in, and from 12 volts, it'll kick out 30, 60, 90 watt PoE as well.
Wow.
So you can do some interesting things there. It's a really good match to have a curb radio and an IE3100 or even the IE3500s that were announced. They don't run off 12 volts and do PoE, but they're a good match, especially when you start talking about forklifts. If you're in a situation where you need multiple ports or you maybe need to be able to do things with identity services engine or have some sort of access control running at the vehicle to keep devices on or off that edge network. If your infosec guys are a little bit more stringent around wanting to regulate those ports. Right now, we're not able to do downloadable ACLs and do ICE enforcement on the ports on a curb radio. I think that's something that we'll see in the roadmap eventually, but for now it's not possible. So you can take an IE 3100, throw it on that vehicle, get the 3100 powered from 12 volts, and it'll kick out PoE. And then you can do all the ICE things, all the .1x things on that switch. So whether you're plugging in a radio or other sensors or other critical equipment for monitoring, you can do .1x and do MAC address bypass and all those things right on that
But
switch.
I swear, as you were, as soon as you started talking, you mentioned the 3100. I was like, well, you can just move all that right to that 3100. And I'm a big fan of the Cisco IE industrial switches. So yeah, everything that you're talking about, you really wouldn't necessarily need to have on the radio, because you can just do it on that inexpensive little switch and take care of it right there before it even hits the AP. So
Yeah, for sure. And the one thing about 17.18.1, it's a new release. So it's the feature of curb and Wi-Fi concurrent usage. I think that's being called an early release feature. So we're definitely not encouraging anyone listening to go deploy this in production right now. This is something that we recognize this is new and there may be a little bit of growing pains with it. So please take it in the lab, work with it, deploy it in places that are maybe not critical. And then maybe as we move into the fall, when the software revs a little bit, then you'll be comfortable and ready to deploy it into prod. But we're not recommending that right now. It is an early release feature. And one super important thing to know is we do have centralized config and we can push all those things out. But if you have existing curb radios, existing 90 IW 9100 radios running in URWB mode, you do have to flip the boot image, flip the boot mode. So boot mode cap WAP. You have to boot them into cap WAP, get them to associate with a controller. then they act more like a wireless LAN access point than a standalone backhaul radio. And then we're able to use the policy tags and use the site tags and everything from the 9800 to push that URB profile back out to the 9165, 9167. So it's a little bit confusing to be able to use the 17.18.1 code and to be able to use the controller-based wireless backhaul control. You have to flip your wireless backhaul radios into CAPWAP mode, which previously was only for Wi-Fi. So flip to CAPWAP mode, let it associate, let it pull its image, and then you can start staging configs and then move it back out to the field and go from there.
So the moral of that story is it's not something you can just add right quick. It takes some planning and some downtime to get the actual configuration up and running on that
I would
newer
recommend an
controller.
outage window, yes, for sure.
Okay. No, that's awesome. Regardless, still that's a pretty big deal if you have the time to be able to make that conversion and then consolidate command and control. That's awesome.
And then what are some of the like hardware requirement changes, right? Like is the mesh end or the coordinator, are you still required to have a dedicated mesh end, or does that functionality go into the 9800 as well?
So you're still going to need the coordinator. So he's going to more or less sit outside the WLC and manage all of those MPLS connections you're establishing in the field. And then the controller is just going to configure the coordinator.
So you'll still be able to do, say, redundant mesh ends with Titan failover, but you're just pushing the config from the controller to those individual radios, correct?
That's right. I like to think of the controller as a configuration management platform, where previously we were using IoT operations dashboard and Racer for those FM devices. So this is going to be our more mainstream Cisco configuration management tool.
So it's kind of taking Racer out of the cloud and just putting it local.
For the most part, yeah.
Okay.
And then we typically in a lot of our app, I mean, depending on the application, but you can use, if you have 9165s deployed and it's not a huge number of infrastructure radios and clients, you can use a 9165 as the mesh end as well, or dual ones, but typically we'll go ahead and just put in a 9167 in that role, or the IPC, like the dedicated mesh end hardware, our coordinator, excuse me.
Yeah, so the rule of thumb there is kind of your total aggregate throughput, which really depends on your vehicle density and also per vehicle throughput. And think about the radio as just kind of processing all that information. So the more data you're processing, the more MPLS connections you're processing. Typically, you want to go, I'd say start with the 9167E if you have less than 1 gigabit of total traffic. If you're above 1 gigabit and below 40 gigabits, that's where you want to go your IEC 6400. And that's a dedicated.
That's the dedicated, like, actual control device, right?
Yeah, it would be a server grade gateway or coordinator for that URWB MPLS network you're deploying.
In Fluidmesh speak, it's like the new version of like the FM 1000. Is that kind of, am I thinking?
Well,
correctly?
or would that be more like the FM 10K?
So I like to think of it, so the FM 1K, so up to 1 gigabit of throughput, the direct replacement for that would be the 9167E. So you can go up to 1 gigabit, and it's also more cost effective than going to that server grade IEC 6400. And then the 10K, that would be the IEC. But the IEC can now do up to 40 gigabits of aggregate. So if you have a higher throughput fluidity network, multiple vehicles, I would go with that, and then double up if you want to do HA or Titan like configuration.
And it's really easy to get over 1 gig if you start putting any kind of like cameras or any of that stuff going across that.
I told you, cat videos. It's where
cat
it's at.
videos. I was just gonna say,
that's right.
4K Ultra HD cat videos.
Right.
The crane operator needs them.
Clearly.
Yeah, ultimately it depends on your use case, your KPIs in terms of throughput, and just putting in the right product for that use case.
Now, and this might be a good time while we're kind of talking about some of this stuff too, like in the roadmap down with the new 802.11 simultaneous modes, right? Are there any plans to have like a checkbox that you can flip on for like survey, so that way, say something like, like Ekahau or Hamina or Cytos is able to capture some sort of beacon from that and process it for just your, to be able to do like a walking survey on that? Or is
What do you,
it,
and to add to that, what about just spectrum monitoring? The CWNP Wireless IoT Track is the only certification program available that not only covers wireless IoT protocols in common use, but IoT as a technology and solution that is revolutionizing industry and business at the same time. When you work through the IoT track, you learn the protocols, the devices, the data, and the applications that bring the true value IoT has to offer. And for those with the tenacity to persevere, the world's elite IoT certification completes the process and the certified wireless IoT solutions expert credentials. If you want to be in the cutting edge of what's happening in technology, you won't find a better certification program for the Internet of Things.
To be honest, Matt and I don't have that roadmap. It's definitely something we can bring up with our product managers and business unit. But I mean, I think the writing's on the wall. Whatever you're kind of seeing with Wi-Fi will eventually be there on CURWB. If not, then Matt and I will kind of take action there and see where we can push it and how we can implement that beaconing and having better
because
integration.
I have a current plan to that's kind of part of why I built that backpack for that demo, is to try to take a client radio that associates to the network, capture the telemetry stream, and then spoof an 802.11 packet, and then just feed it. Because with the Hamina stuff, you can use like a WLAN Pi to connect into it, so to give it like a fake, like a fake beacon frame that can associate it. So then you get it in, you get it in your regular like survey tool. But for what we use most of the time, if we get GPS or position data, we use that commissioning tool that we developed internally. And Igor, Scott, I don't know if you've ever had to do this, or Matt, but I don't know if you remember the old school, like you'd have to send your PCAP off and do the post processing, and then you just got that GNU plot that was just a billion squiggly lines.
Yep.
And then you're like, does this have a square, or is that a plus sign, or is that an asterisk?
So for those who weren't familiar, when Jeremy presented it at Wyco, Tennessee, he built a Ghostbusters backpack with several CURWB radios, and we were going to put a buddy of ours, Ali, in a pair of rollerblades and push him across the parking lot to demonstrate fast roaming.
No, he did. He got on there.
Did he?
We got it out.
Did you get the jetpack on there as well, or no?
No, I did want a
Hoverboard.
little like a little ectoplasm blaster thing on there. But
Okay.
I didn't have time for that.
So we'll get pictures of his Ecto One backpack, and we'll post that in the show notes so everybody can see. I don't know if it met the 1.21 gigawatt power requirements or not, but I'll let Jeremy attest to that. But being that he's still here, it didn't fry him. So
Well, where we're going, we don't need wires.
that's true.
So, and this might be because Igor, just so that way nobody reaches out to you, like I do, and asks you for a document that I should know where it is because you've already told me 5 times. What's the best, what's the best kind of like reference source for somebody that has, Cisco connections, has these devices? Like, where's the best place to kind of find like configuration documentation? Because I know for like the point-to-point stuff, there's just a really simple, clean, straightforward document that says, check this, send this, here's the CLI commands, boom, you're ready to go.
Yeah. So there's a couple different avenues to find that info. So there is publicly facing kind of configuration guides, hardware install guides that you can kind of Google search. So me personally, I just start with the product name and then whatever I want to learn to configure. And then for those Cisco customers and partners, definitely leverage Sales Connect. So you're going to have a Cisco login, get into there, and then you'll have a better repository of TDM decks. So it stands for Technical Decision Maker. CVDs, so Cisco validated designs, and then ordering guides. So if you guys want to understand the pieces, how much they cost, the 3, 5, 7 year licensing scheme, and also what that unlocks, I would definitely start with the ordering guide. And then also there's some other great public facing content like unplugged connectivity. So there's a big YouTube channel there that's hundreds of videos of all things Cisco Catalyst and Meraki Wireless. And there's a couple episodes there with URWB. So definitely check that out. Just kind of string search your the technology you want to learn about, and also kind of.
And Igor, I'll get. I think I've got where you sent that in a message, or if you could send me those, we can put those in the show notes too, so that way people can access those easily.
Yeah, super easy one to remember too is cisco.com/go/curb. So /go/CURWB. It'll take you to product page where there's CVD notes, product overviews, case studies, and kind of branches off from there. So if anybody doesn't know, if you go to cisco.com/go/whatever, /go/curb /go/industrial ethernet /go/Wi-Fi, pretty much anything will take you to where you want to get to just using that kind of built-in URL shortener.
Man, talk about leaking the strats here. That's good information.
You mentioned Meraki. Backtrack a second here. Any sort of CURWB integration with Meraki going to happen now that Meraki's kind of like completely absorbed into the Cisco ecosystem?
Yeah, so that's a great question, and I'm not exactly sure what's coming, but the writing that I see on the wall right now is we're in late stage EFT or early field testing for Cat 9800 controller being managed through Meraki dashboard. So that's a thing.
Wow.
We could for sure talk about that on another episode or whatever if you'd like, but I have it running right now where I've got a Cat 9800L that's managed through Meraki dashboard, and I'm able to see I'm still running Catalyst wireless. I'm still running 17.15.3 right now. So I haven't moved to 18, but I will. But in 17.15.3, I can see my controller in dashboard. I can see all my APs in dashboard. I can see all of my clients and all of my everything, just like it's Meraki wireless, but it's still Cat wireless. So where things get interesting is what's that mean for a 17.18.1 code train? So I've got 17.18.1 on my Cat 9800 controller. I can enroll my Cat 9800 controller in Meraki Cloud monitoring, Meraki Cloud management. So does that mean that I'll be able to manage my URWB tags and manage my site tags and everything for URWB through the Cat 9800? I'm not quite sure how that works yet. I think those are some things that Igor and I will work through in the next 30, 60, 90 days. And we'd be happy to come back and talk about that or show you what it looks like.
Yeah,
But
I'll be
I don't,
bugging
I
you
don't,
because that's something I want to know because I mean, and I've said this for a long time, the Meraki dashboard and their cloud space, and being in the industrial manufacturing universe, I'm not the biggest advocate for cloud, but back in my enterprise Wi-Fi days, I said it 1,000 times, Meraki by far has the best, most intuitive cloud-based platform, and I've always been a fan of it. And so the eventual integration of CURB functionality in that would be just phenomenal for non segmented industrial applications that don't have any sort of internet access.
yeah, I agree. I think it'd be great. We'll see how it goes. The
Is there
Meraki
any
Dash is really good.
is there going to be any like adaptive resource stuff that's going to go, that'll be applied to CURB, like power, automatic power channel, changing and stuff like that?
So
I don't know.
been announced. I mean, my gut feel that's going to be later on, like a phase 2, phase 3.
I mean, obviously you're not going to want to like switching channels on you or anything, but having like a range of powers.
Yeah, I mean, hopefully we can start implementing transmit power control, frequency selection, and eventually pull that up to AI RRM in terms of kind of just self-healing, self-managed curb networks. But I think kind of the first step is just understanding how this is going to work on the controller and then fine tuning and further integrating to those mature Catalyst products.
I just thought of this, Squirrel, backtrack a second. When it was Fluid Mesh, it did not necessarily operate on 802.11 defined channel spaces, but now it does. That was a Cisco transition, was it not? Or am I just completely off base here? Because I don't remember the FM45
Well, I
using
think in the
standard
drop
like
down,
channel.
most of those were based on Wi-Fi channels where you'd select the frequency and then the width. But I think you could go to like 5 megahertz widths and stuff like that, right, Igor? Is that, or am I imagining that?
No, you're correct. So the legacy Fluid Mesh gear, we go to a 5, 10, 20 megahertz wide channel.
That must be what I was thinking of then. Okay.
So now, I mean, we're going to be more along the lines of your standard Wi-Fi channel plan, but also URWB extends into 4.9, so we can do that public safety spectrum, and also 5.9. So they're kind of the lower and upper bands outside of that Uni
But those
1.
would require licenses to operate, correct?
Yeah, don't just turn it on and
No, yeah.
actually I think now there's like some I think there's some like interlocks that prevent you from setting that.
Yeah, so right now that license is lightly managed through IoTOD. So eventually we'll find a way to do it on the controller. But you more or less have to go to TAC and say, hey, I want to do 4.9 in this area, fill out some paperwork with the FCC, and then they'll grant you that free license to operate and configure in 4.9.
Yeah, FCC doesn't like it when you do stuff without their permission.
Yeah, but I've yet to see an FCC police car driving around, so.
While that's true, I have seen the FCC slap some fines on some people to the tune of $500,000 for things they should not have been doing. Marriott learned that the hard way. I don't know if you guys are familiar with that story, but that's a conversation for another day.
Well, when you do your Wi-Fi Explorer scans, if you see FCC surveillance VIN, you know you're hosed.
That's true. That's true. Although that's usually Jeremy because he's war driving on you.
No, I would never. I don't even know what that is. No, actually, I would. I've thought about doing that, getting into that wiggle stuff. That seems like fun, but
Wiggle's great.
I don't know that my wife would like me like having wireless gear just on the dashboard in her car when we're going out to dinner.
I just don't have the time for that stuff, man. Between the show and work and family life, I don't have the time to get into that. I mean, I just like throw it on my workbench and dissect it and see how it works.
Yeah. Well, Scott, I know we kind of hit some of like the updates and a little bit on the hardware. Maybe you guys, if y'all have like an interesting project that you've worked on that you can talk about, just to kind of like showcase some of the capabilities. I think that might be worth spending our last little bit of time on that. What do you think about that?
Sure, let's jump in. Well, I guess I can get started. So I'm not going to name any specific customers, but some of the common use cases and verticals that we see with CURWB is, say, like digital divide, digital equity like use cases. So say providing public Wi-Fi outside from that building edge, that ISP connection. So think of a point-to-point, point-to-point relay, point-to-multipoint with CURWB, and then Wi-Fi as your client serving AP, and kind of rinse and repeat every 200 or 300 feet, depending on where that vertical asset is.
You're talking more along the lines of like metro area Wi-Fi and whatnot.
Yeah, metro could be rural.
Okay.
It could be private connectivity on a campus. It really depends, but obviously it's going to be easier to deploy this in a rural environment with less interference than, say, downtown New York City, for example. DOTs, so interconnecting traffic light cabinets going a tenth or a quarter mile at a time. So next time you guys are at a red light, pause, take a look up. If you see a camera in the white box, chances are it's a 5 gigahertz backhaul. Could be a Ubiquiti Nano Beam or a Cambium PTP. In some cases, it could be a Fluidmesh Volo or the 9165D. So I'd say those are kind of like your low-hanging fruit, can be applicable to any vertical. And then the next big one I've seen is manufacturing and AGV connectivity. So that's kind of a blended IT, OT like environment because every manufacturing floor I've been to has had Wi-Fi coverage and more or less pervasive coverage. And that's where it gets interesting because now you can kind of mix and match and unlock CURB on one of those radio slots. So with this new announcement, it could be, say, a CW9178i. So quad radio, 2.4, 2.5s, and 1.6. And you can configure that slot 2 or 3 for CURB connectivity. Ports and terminals, fluidity there. So using that high mass light pole, there's a typically 100 feet off the ground. Doing sectorized horn antennas, down tilt them, and provide vehicle connectivity for terminal operating system control and more or less asset tracking of those vehicles. And in some cases, going partial or fully teleremote. So now you're starting to dial up the throughput and the latency requirements. But definitely a use case that we've seen and configured too.
So back in the day when it was fluid mesh, one of the big things that fluid mesh was really known for was high speed rail over in Europe. Is that still a primary driving use case, or is that kind of faded off to other stuff, or have you just expanded on that since then?
So it definitely is still a primary use case. And to be honest, it's kind of the go-to wireless solution for some of our vendors, especially the ones I used to work for. And yeah, we can provide high throughput, high speed roaming up to 300 miles an hour on, think of some of those bullet trains out in Europe, Italy, APJC, and also people movers at airports. So that's where I used to work at. That's where I first got introduced to Fluid Mesh. We tried Workgroup Bridge. It was a break and then make connection. But Fluid Mesh, CURB provided that seamless connectivity as the train was moving, as long as you have coverage and good line of sight. And think of it now, you could say have Wi-Fi client access in the train on radio 2, and then radio 1 is your CURB backhaul link as you're roaming from station to station, and eventually that maintenance yard at the end of the night.
Yeah, that combination of backhaul and then emitting that small little bubble of Wi-Fi like Matt was talking about earlier, I think that's a pretty big deal for the mobility game. And I think that if it hasn't already, it's going to open a lot of doors for a lot of different deployment types.
Yeah, and in some cases, if you're having, say, a private 5G conversation with your customer, you could also talk about CURB and fluidity and kind of a build your own network. You're going to need more radios, but you're still going to have a robust, high throughput, low latency network to offload into.
Well, and to be fair, I didn't even know until recently what the difference between Fluid Max and Fluidity was, because I've only ever deployed it in a Fluidity mode. Learn something new every day, right? But see, Jeremy's the guy I call whenever I have issues because he's done so many more deployments on these than I have. So I'm all texting him late at night, you know, trying to figure out what the problem was, and it turns out it's the guy I'm working with doesn't know what where the console port was, and it was trying to serial into the secondary Ethernet port and wondering why it didn't work. But that's okay.
Like you do. That's we've all been there.
Well, I just don't want to get don't want to get those texts confused with my normal late night drunk text that I send you. So
Cat video links.
Hey, check out this hula cat. And Matt, you do a lot of your stuff. You do a lot of like distance testing stuff, right? Or do you do a lot of fluidity, or are you primarily like a point to point?
Yeah,
Point to multi-point?
both. Yeah. Igor and I've done a lot of fluidity stuff for various customers, and one thing that I see happen in fluidity environments, especially in manufacturing environments, is sometimes we have AGVs or we have assets that move around through the manufacturing process that we need to have completely resilient communication paths to. So fluidity is great for that. But the other thing that brings along with it is a lot of the manufacturing customers I've worked with, their floors are extremely dynamic. Today we're making widget A, 3 weeks from now we're making widget B. We have to be able to move all of our equipment and retool the line, and man, my cabling guys are going to kill me when I tell them I need Wi-Fi here, I need Ethernet here. I've got equipment that can't be Wi-Fi, that can only be Ethernet here. I've got devices that only speak serial that need to plug into a serial to Ethernet bridge, and they need to live here. How do I deal with this? And so one of the interesting things that comes out of having a really robust fluidity deployment is I can put a 9165 anywhere as a fluidity client. And wherever I have a 9165, I have an Ethernet interface into the network. And I can put that on whatever VLAN I need to, whatever network segment I need to. So even though fluidity is primarily looked at as I need support for objects in motion, we can also have support for kind of Ethernet ports at motion or Ethernet ports that are migratory. It's
Mhm.
they're it's not an 8-pound coconut, but it's a 9165E and it can migrate. So we can
That
we
being
can put
said, can you run multiple VLANs across that? And is it going transparent, or is it just more you gotta slap it into an access port and roll with it?
Yeah, so when we're talking 65E with that Ethernet port, we can have one VLAN defined as native VLAN, and if any traffic is dropped in without a tag, that's where it goes. Tagged traffic gets handled appropriately across the trunk link. But if you have assets you're plugging in that can't do .1Q tags, then you do need a switch, and you need to peel that trunk port into access ports and drop those access ports into the native VLAN for your devices to plug into, so that you can
Okay.
get the traffic tagged. So
Okay.
um, and some of that is a little bit confusing, but maybe we'll work up kind of the introduction to native VLAN, tagged VLAN, and work through a few scenarios. I've sent some things out to customers that show if you have a packet with no tag on it and it goes into a port configured like this is where it ends up. Or if you have a packet that is tagged and it comes into a port, this is where it ends up. So maybe we can make kind of a flowchart thing and talk about that. But so we do a lot of those things, a lot of fluidity things, but also have done quite a bit of the longer range tests. We've done some 10-mile tests, and I've hung out on the top of 200-foot towers out in the middle of the desert for some specific customers. So done a lot of the 1 mile, 2 mile, 5 mile, 10 mile work with 9167s and 9165s. Do a lot of that with National Guard and with DoD customers and things like that. So yeah, kind
So
of
on
all over the place.
on things like that, are you having to like, because I know like in 802.11, like you might manipulate like the guard interval or something like that to be able to make that, that distance, the time in the air. Are you doing any of that kind of stuff with it?
Yeah, so there is, if you drop into an IW radio, there's a location where you can fill out the max distance link that you're using. And when you fill out that metric, it adjusts the timers, the whole speed of light, Ethernet and a wire versus Ethernet protocol over RF. The ACK timing can be off, and if the ACK timing is off by a significant amount, it will prevent a data link from coming up. So using that configuration box where you put in the distance of your link is where all of that kind of gets trued up and aligned. And we've seen some interesting behavior with that in some different versions of code. So Igor and I are continuously working with our development team and working with some of the platform experts to make sure that calculation is refined and is accurate. So that is a thing that sometimes we have to futz with. Sometimes if you're working on a 10-mile link, you might have to set that particular metric to be 12 or 13 miles to get the ACK timing to align. So just a few growing pains as we transition from the fluid mesh hardware to the IW hardware and software.
And then I think that one of the things that you just said, maybe with the VLAN tagging, a lot of times we'll run into stuff too, where it's like, if you have more than just controls traffic running across a link, then you also might need a switch that can do like QoS tagging. So that way you can put things into appropriate buckets, do that, and then you'll remap the COS traffic in the radio itself, so that way it puts that controls traffic in the higher priority. And then sometimes you have to manipulate like the packet aggregation and stuff too, because either you want it to aggregate packets or you want it to just spit them out as soon as it gets them for certain ones. So there's so many nerd knobs in there.
Yeah, there really are.
Yeah, for those mission critical PLCs we're backhauling, obviously our best practice there is enabling QoS and sending that frame off as quickly as possible.
And I think kind of that point of like, roaming or like mobility or like the fluidity, like it's not always like a device in mode, it might move once every 6 months, right? But it might need to change location. So that it's interesting to think about that. And I mean, we've got some applications that we've done where it's a point to point, but it's not necessarily fixed. Like, if it's only ever expected to connect to one radio, like it doesn't, as long as they stay in the appropriate coverage zone, they can move all over the place and still stay connected. So it is interesting to kind of like think, not be tied to like, oh, well, a point to point is only when you put a radio on a pole and whatever, right? Like it could be a mobile crane, or it could be two moving devices that need to talk with each other.
Yeah, we've done a lot of kind of ad hoc deployments like that. So think of like a temporary camera stand with a curb backhaul. And you can even
Mhm.
configure that radio to do channel scanning. So if you set up that tripod in a different area with a different frequency, it would trigger that channel scan, find the channel, and then associate to that AP.
Yeah, I can
And
see
we
that with those mobile security posts like you see in parking lots at Disney and different theme parks and whatnot, where they just up and move that little trailer here and there. It's got the one lone security Barney Fife in there with all his camera feeds and whatnot, sitting out in the middle of a parking lot.
Yeah, I mean, there's a lot of cool things you can do as long as you have spectrum, line of sight, and good coverage. You can do fixed or mobile connectivity. And that's, I think, one of the benefits of URWB. It's a wireless tech that does fixed and mobility extremely well. And I don't think anyone can compare with our 0 millisecond handoff. So for those mission critical connections to PLCs or say CBTC traffic on a train, I would definitely start there because it's cheaper, it's unlicensed, and then after that you get into specialized radios and licensed frequencies, and it gets expensive.
and that's you said spectrum, and then it kind of prompted this thought too. You have also, since it doesn't beacon, you do if you put it in concurrently with another system, you do also have to be kind of aware of what spectrum you're using for your curve deployments, because you can create like I guess it would be considered like OBSS interference in a sense, in that a 802.11 AP is not going to pick up a beacon frame from that, so it's not really going to know it's there, but it will detect it as it'll consider it noise essentially. So you do have to kind of manually block those channels that you use for these deployments off from those systems so you don't step on them.
Yeah, and that's been more or less a best practice. So obviously do a spectrum site survey, see what's occupied, unoccupied. And if you have the ability to change it or say, hey, stay away from channel 165, for example, you might reserve
Mhm.
that for curb and then have everything else run Wi-Fi.
And
Um,
if you're a real nerd, you can get a Wi-Fi adapter that can go into monitor mode, and then you can promiscuously capture it in the air. And then you just have to be able to parse the packets to read them.
Yeah, and there is a scanning radio that's present in the IW series hardware. It's not lit up and it's not supported yet, but hopefully that comes to fruition, sooner rather than later, and then we'll be able to monitor for curve deployment, and we'll be able to use that for monitoring just spectrum at large. And then we're watching to see if the RF plans in the Cat 9800, if you spin up wireless backhaul channel usage, does the RF plan automatically update, and how does that work? I think right now it's not. You have to go coordinate all of that kind of on your own. But it'll be interesting to see how, as the software matures and as we move forward, how we see better integration between coexistence of Wi-Fi and curve across the spectrum space, and maybe we get to a point where we have RRM that's able to tell what's going on in the spectral space and then modify channels and modify widths and everything in real time. That would be an interesting thing to see for sure.
And I think it really is nice seeing kind of how thoughtful this product has been treated too, like with the developments. It's the same old, like, right, what's the minimum viable product? Okay, we've got the hardware, it can do this, and then now, like, let's start adding features into it. And I really love the fact that, you get multiple radios, so you're not daisy chaining two radios together on a vehicle, or, we've had 4 or 6 on some applications and stuff. So I really like the hardware from a deployment standpoint. Like it's very flexible.
Yeah, I mean, it's more or less becoming a software-defined radio. So CURWB, Wi-Fi, clean air channel scanning, for example, too. These are all just different modes that we can configure into, and will be managed by Catalyst Center and the 9800 controller going forward.
Igor, have you done a bunch of we've only done a few of them. Usually it's like a flat network that we go into, but what are some common kind of pitfalls when you're crossing like a subnet, or you have like things like, like a client vehicle or like a separate segment on one subnet connecting into that? How involved is that, getting that set up? I don't know if I asked that in an effective way, but
I mean, I like to say draw out your architecture first, get it right on paper, and then go configure it on the APs and also stage them before you go out into production. And also determine, is this layer 2 or layer 3? Because that's going to change your configuration and your hierarchy of gateways or coordinators that you'll have to use.
because I know sometimes we'll run into things where like if a vehicle leaves one building and goes to another building, and that building's on a completely different subnet, then you have to have ways to do that. And I think there's well, I don't think, but there's, right, like you have to configure like internal static routes on the radios and stuff, right? Is that still the same from the Fluidmesh?
Yeah, for the most part. Because you're now doing kind of layer 3 fluidity, and each vehicle is more or less its own unique subnet, and you're roaming from one subnet to the other, and you may need a router on board that vehicle. So it starts complicating the architecture and also the price too.
Yeah. So that's probably avoid it at all costs, or unless you absolutely have to.
Yeah, I mean, I'll just draw out the different options, see what makes sense, both architecture-wise and then also budget. That's always something top of mind with all of our customers today.
Yeah. And then what are, I know you like that. Is it Cloud RF? Is that the planning tool you like to use?
Yeah, I've been using Cloud RF for about 5 years now. So I just more or less create my own CURWB radio, and they have awesome clutter maps. So both like man-made and natural structures. And it's a good line of sight check, because a lot of times I start off with Google Earth, do a street view, do a crude elevation profile, but without really understanding the topology and the line of sight obstructions. Cloud RF's definitely a good start. And then the best option is going out into the field with some radios like Matt and I have been doing, setting up the radios, aligning them, finding the signal strength, and getting some of that empirical data, and hopefully using Prism stats to collect that telemetry too.
Yeah.
Nothing beats field testing, man. Nothing beats
it's hard to
field
beat.
testing.
Yeah, even with some of these modeling tools, I mean, there's still models with a certain margin built into that RSSI, but until you validate it and kind of stretch the RF, it's kind of hard to see.
Well, it's like, okay, you're putting a point in an electric drawing, and you're putting another point in an electric drawing, and then it just, verify, it just runs the numbers through an equation and spits something out. And then you might put like a rectangle or something there, but it might be, you can't accurately predict like how something's going to do in a material. So it gets you pretty close, but it brings me back to statistics classes and confidence intervals, which give me nightmares. But it's like I'm 95% confident that this is accurate, right? But then there's still like the unknowns that you have, and maybe not always 95%, but yeah, field testing is the way to go.
This is going to work great until it doesn't.
Well, I put the dots down, and I had green everywhere. It's like, yeah, but you didn't think about the fact that like the operator is set as lunchbox on your antenna, or whatever it is.
But Jeremy, it was green, so that means it's going to be fine. Because green means good on everything.
Yeah. Well, we're close on time, and I know Igor's got some meetings, so
Guys, I
Yes,
want
ma'am.
to thank you a whole lot for taking the time and joining us on the show. Fluidmesh, which then became Cisco Ultra Reliable Wireless Backhaul, is a really dynamic, flexible platform. There's amazing integrations coming with Cisco controllers and possibly with Meraki controllers. That's going to be interesting to see how that plays out. If that becomes a thing, we definitely want to have you guys back for an update and kind of go from there. And I really appreciate you hanging out here at the Industrial Wi-Fi Shop.
Yeah, thanks for the invite. It's a great time.
Yeah, thanks a lot, guys. Looking forward to the next one.
Thanks for listening, everybody, and we hope you join us on our next episode of the Industrial Wi-Fi Shop.